All right. So you're going to want to take out a piece of paper and kind of have your notes handy because I'm going to do a little bit of both just to make sure that you understand. Okay, so on the first one, this is a warm-up. I want you to think about answering these three questions. State the parent function. So that would be like constant, linear, quadratic, or absolute value. Can I just put absolute value just because? Okay, describe the transformation. So that would be like translation, reflection, dilation. Those are the three that we learned. Okay, so I would like you to pause the video and just do number 1 and 2. We'll talk about sketching the graph, but I would like you to do 1 and 2. Pause. Okay, you paused. So if we look at question 1, what is the parent function? The parent function is quadratic. How do you know it's quadratic? Because the function has a square in it, so it's going to be a parabola. Okay, and so I'm going to mark these. This right here, oh, I don't want the x in there. So the +2 is a type of transformation. And if you look at your note cards, the +2 is telling you it's a translation because you're adding. And it's horizontal because you're going left and right. And you're going left 2, right? I'm not going to ask you to describe on every single unit we do, but on this first unit, you're going to have to describe. Okay, and then I'm going to look at this other one. This -4 is outside the parentheses, and it's an adding and subtracting, so it is a translation. It is outside, so it's vertical, and it's going to go down 4. Okay, those are the only transformations that I see. Okay, so now it wants me to do 5 points in graph. Well, if I do what I know that 1 point. I know that this is left 2, down 4. So left 2, down 1, 2, 3, 4. That is the vertex point. So if I know that, then I could put in a -1. Oh, why did I go? Sorry, guys. Left 2. I went right. Left 2, down 4. Okay, so if I put in a -1 into this equation, that would be a -1 plus 2 is 1. 1 squared is 1. 1 minus 4 is a -3. So I would have a point at -1, -3. And that also means wouldn't I have a point at a -3, -3, because it's symmetrical. Okay, and then you're going to go ahead and put in, you have graph paper, I would practice it. So if I put in 0, that's going to be the same as a -4. So I'm going to go ahead and put 0 in there. If I put 0 in, I would get 2. 2 squared is 4. 4 minus 4 is 0. So I'd have a point at 0, 0, and 4, 0. So this parabola would look like this. Okay, it's just sketching them, and they're going to be nice and simple. Okay, and so I asked you to do this other one. If you did not get it done, try it now. Pause and try it now that you saw one example. Okay, the name of this function is absolute value. How do I know? Because it has an absolute value sign, right? Okay, it has a couple of transformations. Let me just mark them because sometimes I think it's easier to see. This minus sign is flipping it down. So that minus sign is a vertical reflection. So it's going to be a V that goes down instead of a V that faces up. And then let's mark this guy. This is outside. And so that is adding it up 5. So it's a translation since you're adding. And it's vertical. And it's up 5. Okay. All right. So if I make lines on this, okay, this thing is going up 5. It's not being moved right, left or right. So it's going up 5. And then it's a V, so it's going down. Okay, so I'm going to have a point at 0, 5. And then if I put in 1, that's going to give me the same answer as a -1 because it's symmetrical around the 5, or around the 0, sorry. So if I put 1 into this equation, 1, absolute value is 1, but then I take the negative of it, so I'd have a point at 1, 4 and a -1, 4. And then I'm going to put in 2, which also would be a negative 2. So when I put in 2, I would have 3 and 3. So I'd have 2, 3, and a negative 2, 3. So my V would look like this. Yes? Okay, so just a warm-up to this. All right, so state the domain and range, make a table of values, graph the function. Okay, so all of these things are asking you, this is on MF 2, 3, and 4, and we're just putting all of them together, so this is in your notes. So go ahead and find this one. Okay, so first off, we're going to look at graph the function, state the domain and the range. So I'm going to make a table of values, but before I do, I'm going to use a little common sense. This is getting it moved right. If I use what we've learned, this is moving right 4 and up 6. Okay, so if I go right 1, 2, 3, 4 and up 1, 2, 3, 4, 5, 6, it's right there, right 4, up 6. So if I make a table of values, I know that that's going to be the bottom of the V, right 4, up 6. Okay, I know it's going to go up like this because it doesn't have a negative. Now, because of the 2, that's probably going to make it go a little skinnier, but I'm going to plug some numbers in around 4. Like I'm going to plug in 3, that's 1 less, and 5. Because isn't that right there around 4? 3 and 5. So I'm going to go ahead and plug those in, erase these, because then we'll get it exactly. If I plug 3 in here, so I'm going to take, and I'm going to plug 3 into there. 3 minus 4 is a negative 1. The absolute value is 1. Times 2 is 2. And so these points are 8. So I'm going up to 8. So my function goes like this. Okay, it's a V that goes up, and I have those 3 points. Okay, it wants me to make a table of values and state the domain and the range. So if we look at the domain is looking at all of your x's. Can I put anything into there? Yes. So the domain, it's an absolute value, is a negative infinity to infinity. Okay, your range, you're going to look at the bottom of this absolute value. Okay, and the range is at a point that is over 4 up 6. So I'm looking at the bottom y, so it's going from 6 to infinity. So you are going up. Okay, I'm writing those in set. So I sketched it. I plugged some numbers in. I got a graph of it. All right. So on example 2, they give you the equation and now they want you to write, or they give you the graph and now they want you to write the equation. You're going to have a few of these. First off, it is a V, so you know it's an absolute value. Okay, I know it's not a parabola because it's not a U. I know it's been shifted. It has a horizontal translation. Left 1. And it has a vertical translation. Down 2. Right? So, if I look for dilation, and I will tell you right now, on this test, I'm not going to give you a lot with dilation in a picture. I'll just give it to you in the equation like the last one. I'm going up 1 over 1, up 1 over 1. That has a slope of 1, so it basically has a dilation of 1. So if we are going to write the equation of this, I know it's an absolute value that's been shifted left 1, so I'm going to say x plus 1, right? Look at your table if it goes left. And then I know that it goes down 2, so I'm going to put minus 2 outside. Okay, and that is the equation of my function. What is my domain? Negative infinity to infinity. It's an absolute value. What is my range? You always look at this point right here to find your range. Your negative 1, negative 2, and your y value, the lowest point is a negative 2. So my range is a negative 2 up. So you're going to say to infinity. Okay. All right. So let's take a glance at this one. This is definitely not an absolute value, right? This is a quadratic function, right? I know that it's been shifted I can't do left and right now. I know it's been shifted right 3. So it has a translation. Oops. And it's horizontal, which would mean it's inside. And it's going to be right 3, right? It also isn't pointed up. So it has a vertical reflection. Okay, because it's been flipped down. All right, and so if I look at this and try to find the dilation, I am going over 1, and 1 squared is 1. I'm going over 2, and 2 squared is 4. So to me, it's just squaring. It's not multiplying by anything, so it has a dilation of 1. But again, please don't panic too much about dilation right now. We're just introducing this, so I'm not going to give you a lot with counting a dilation. I would give it to you like I did up here in the equation, and then you have to graph it. But we're probably not quite ready to see it, but we're going to start talking about it. Okay, so if I write the equation, I know it's a parabola and it's gone right 3. So since it's gone right 3, I'm going to do x minus 3 parentheses squared, because it's going right 3, so you have to minus 3 inside. Now, if you look at your form and you look at what a vertical reflection does, that flips it down, so you have to put a negative sign outside. And that would be the equation. My domain is going to be a negative infinity to infinity. And my range, now this isn't the lowest point, this is the highest point. Sorry. My highest point is at 3, 0. So I'm looking at the 0. So my range would actually be from a negative infinity to 0 with a bracket. Okay, now some kids write 0 to a negative infinity, and I would not take off for that. But when you get into calculus, when you integrate, you are going to want to go from bottom to top. So I'll always write it that way. But if you have it in the other order, so if you wrote 0 to a negative infinity like this, I would accept that as an answer. That is not wrong. It's just another way of writing it. Okay. All right. Now this one, read the questions in your homework very carefully, because it's not even asking to graph. It's just asking, does it have a max or a min? It's like a yes or no question. And so if you think about this, it's getting shifted left 2 and down 4, right? Okay, and that doesn't really tell me whether it has a max or a min. What tells me if it has a max or a min is this sign. So this parabola, if I just sketch it, is going to be left 2, down 4, and then it's flipped. So, and it would even be skinnier because of the 2, but we don't even care about that. All I care about is it pointed up or down? And all I have to do is look at this right here to know. So on your homework tonight, you literally just have to look at the equation and say it has a max because it has a negative sign and it's pointed down. So if I follow that same thing, this does not have a negative sign on it. So that means that it's going to be pointed up, which means that it's going to have a min. This is all that is asking you to do, max or min. It's not asking to graph it. It's not asking for domain or range or anything. Okay. All right. This is also on your homework. You notice it's green, and that's just because they're practice, and I didn't really write them down, but I don't think it should be too bad. You're going to have some tonight that it just wants you to identify the type of function. That's all it wants you to do. It's not going to be multiple choice. It's just going to be like a picture like this. So if it looks like this, if it's a V, then your answer is an absolute value, right? Okay. If it looks like this, what is my function? Quadratic. If it makes a U up or down, it's quadratic. If it makes a V, it's an absolute value. That's all we're talking about right now. Okay. This is a horizontal line, which means it has no slope, right? It has a 0 slope, I guess we should say, because it's a flat line. And I had somebody today that was like, that guy would just walk forever. There's no slope. Right? So this is a constant function because it is horizontal. If it had any slope at all, like that blue one I just drew in there, then this would be linear. Okay? But if it's a flat line, it's just constant. It's just staying one value. Okay? All right. This is something I'm going to talk more about But I talked about it yesterday, and you don't need to write this down, but I just like to watch to make sure you understand. It wants recording, please. Oh, good. Whew. I don't want to cancel yet because I'm almost done. It wants to see if there's a difference between the 2 on the inside and the 2 on the outside of an absolute value. So I'm going to go into Desmos. Again, I apologize that I can't use my other calculator, but it doesn't really work. We talked about this yesterday. I'm going to hit it up again. So if I do the absolute value of 2x, it's that red graph. If I do 2 times the absolute value of x, it's okay, they graphed on top of each other. So on absolute value, does it matter if you put the dilation inside or outside? No, because you're making positive. So it doesn't matter if you multiply and make positive or make positive and multiply, you're still going to get the same answer. Okay, and that's really all I wanted to talk about with this one. I am going, similarities and differences, they're the same graph. I am going to go over this again next week when I'm there. It's not really imperative for you on this homework assignment, but I feel like if I talk about it a ton, maybe it will sink in. Okay, now let's talk about this. Okay, it's same thing, inside and outside. Okay, so if I do parabolas, and so we talked about this yesterday, if I do a parabola and I do 2x parentheses squared, it looks like that, right? If I do 2 parentheses x squared and I put it on the outside, those are not the same. Okay, so it does matter on a parabola whether you put it inside or outside. Okay, and we're going to get into all of that, but I just want to make sure you understand. So the last one, it wants to know, so you have, you have this one, and we know for sure it's different than this one, right? But now I have a question, okay? Is this one the same as either of those two? So no parentheses at all. So let me type that in there and let's see if it graphs on top of green or red. So what if I just type no parentheses and do 2x squared? That just graphed on top of the green. So that's like writing it on the outside. So I just want to make sure everybody understands these two things are the same. And again, this is not something you have to master right now. We are going to work on this a ton in the upcoming weeks. I'm just introducing this all to you and we're going to mess with it, okay? So I would just make sure you're going back and figuring out what you've forgotten about lines. Lines were not during quarantine. You did lines in 6th grade. You did them in 7th grade. You did them before quarantine in 8th grade. You did them in 9th grade. So lines, you're just going to have to kind of fight through that and figure out what you've forgotten. Okay. The quarantine stuff is definitely going to be things we slow down for. Okay, so on this one, let's take a look at this. Now we're putting a translation in there. Okay, so because I said it doesn't matter if you put it inside or outside, so I want to show you something really quick. The first one was absolute value of 2x plus 4. Okay, I thought that if it was a plus 4, it was supposed to go left 4, but it didn't go left 4, it went left 2. So this is something we're going to fight with a bunch all semester. You're going to have to do what you guys love. You practiced it in geometry last year and you were quarantined for it. That's why I was bringing that up. So we're going to spend extra time on this part, but factor. I can take a 2 out of both of those. Oops, I don't want double set. Okay. If I look at that, that's why it's going left 2. You have to factor that out in front. So now if I pull this out, it also graphs. So all 3 of these are the same equation. Okay, so to find your translation, you are going to have to factor out that 2. So if, for example, what if I did, I'm going to write this here. What if I did the absolute value of 3x plus 9, right? This is not going to go left 9. I'm going to have to take the 3 out. If I graph this equation, it is going to go left 3. It's not going to go left 9. And let me show you what I mean. So if I graph the absolute value of 3x plus 9, that does not go left 3 or 9. It goes left 3. And that is because if I pull a 3 out, it is going left 3, right? If I pull a 3 out, it is going left 3. All right. And we just talked about that. I'm not going to do that again. So now go to MF5. This is just graphing. Okay, so I would always start by looking at where it's been shifted. This thing has been shifted. If I make a table of values, I'm going to put right 3 up 10 in the middle. Right 3, 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is my vertex. Because of the 2, it's going to make it skinnier. And because of the negative sign, it's going to flip it down. Okay, so I'm going to put numbers in that are close to 3. So I'm going to put 2 in. If I put 2 in here, that's a negative 1. Negative 1 squared is 1. Times a negative 2 is a negative 2. Plus 10 is 8. Okay, if I also put 4 in, 4 minus 3 is 1. 1 squared is still 1. Times negative 2 plus, okay, these answers are the same. That's because they're symmetrical around the vertex. So if I wanted 5 points, I don't have to do 1 and 5. I could just plug the 1 in. That's a negative 2. Negative 2 squared is 4. 4 times a negative 2 is a negative 8. Negative 8 plus 10 is 2. So I know those answers are going to be the same. So my parabola looks like this. It wants the domain, negative infinity to infinity, and the range, this point is the top point at 3, 10, and the y is at 10. So, sorry, I thought it was going up. Negative infinity to 10. Now, if you wrote 10 to a negative infinity like I started doing, I would not take off. But if you're going to have to take a lot of math, you might as well write it from smallest to biggest. All right, graph the following. I'm going to have to look up what that equation is because it did not go. So give me 2 seconds. I think it was an absolute value if I remember right. But my Google is not being very friendly to me today. And this probably won't open because it hates me. Let's see. Oh, it's coming. There we go. Actually, we aren't. I forgot that that's probably why I deleted that because I wanted to change it. I am not going to give you one that looks like this. So cross off example 2. That's what we're doing next chapter. And I'm not sure. It's not even in the same font as my stuff. So I think someone must have changed that on my notes. We are not doing that. Please ignore it. Don't worry about it. That's why it got deleted off my notes because they did the wrong one. All right, so on this one, all it wants me to do is write the equation of the function. That's all it's asking for. So if I look at where it's been shifted right 4 down 2. And then I would always see it's going up, so it doesn't have a negative sign. And it's going over 1, up 1, that's 1 squared. Over 2, up 4, that's 2 squared. So it doesn't have a dilation. So my answer is x minus 4, because it's going right 4, and then down 2. Okay, this is where you're going to want to use your cards. Okay, help you figure out left, right, up, down. Now, this one is a little harder. I don't know that I would give you one like this on this first test, but I definitely would on the Unit 4 test. This thing has been shifted left 3 and up 4, right? Left 3 and up 4. Now, if I look, so I do know this. Y equals x plus 3 squared plus 4. Left 3, up 4. Now, it is going down, so I do know it has a negative sign, but I think it also has a dilation, and this is really the first one we're looking at. So it should go over 1, down 1, but it's not. It's going down 2. And it should go over 2, down 1, 2, 3, 4, but it's not. It's going down 8. So it's doubling those dilations, so it's going to be a negative 2. Now, if you're panicked about that, we're going to work with that more. This is just the first look at something that has a dilation. That's all. Okay. All right, so on your assignment tonight, you have to state the parent function and describe the transformation. So again, I'm going to pause. I want you to pause the video, and I want you to answer these two questions. This is just the equation. Pause and answer these just on a scratch sheet of paper. So this first one is an absolute value, and it is a vertical translation up 3. Yes, you have to write vertical translation up 3 on this test and this test only. After this test, I won't make you describe them. Okay, the next one is a quadratic, and it is a horizontal translation because it's inside, and it would go right 3. Okay. The next one is an absolute value function. And it's a multiplying by a negative, so it is a, sorry, I should have started with a V, but it is a vertical reflection. You don't have to say by what, because it's just flipping it. Now, the next one, we kind of talked about these when we did notes yesterday. This is an absolute value. I'm not going to give you one with a negative inside because we talked about it just flips on top of itself. But if an equation came up this way, it would be a horizontal reflection because it's on the inside. Okay, the next one is a quadratic. And it would be a vertical because it's outside, dilation. Okay, and then finally the last one, that 3 is on the inside, so that is a quadratic, and it would be a horizontal dilation. We're going to get more into the dilations as we move along. I just want you to be able to label them. Okay, right now it's just a labeling piece. Okay, and I think we'll practice those. This is where we're going to start on Monday. This, after we take the quiz over lines, we are going to work these as practice, as a warm-up, because we aren't going to be moving on right away. All right, good luck.